Hey, I'm Manny from Poppy's. We're gonna be talking about this Ram 5500 that we just scooped up. We're gonna be doing a similar thing on this one, just like on the Chevy 5500 that we're working on. I wanna show you a couple details that's actually gonna make this truck a little bit easier than the other trucks. One of the main things that makes this Ram a little bit easier than the Chevy is the fact that this comes originally with a 4-link already. So when we redesign the front, we might not need such a heavy duty truss like the one that we did on the 5500. On this truck, we might be able to just get by on basically making a truss that'll use the same 4-link bars, or maybe like a longer bar to like a different basket of some sort.
Okay, so here we have a complete assembly of what it is that we're working on. This is the frame rail, and here are all the components that we're installing on the frame rail that are manufactured. What I'm going to explain to you right here is this that I'm pointing out. This is the truss assembly. Everything that you're going to see below there, you're going to see the truss itself. You're going to see the housing. Here you're going to see the bags and the chassis and all the other things that are related to this truss. But this right here, I'm going to go to the sub-assembly of this, and I'm going to explain to you what I was trying to explain that's different on the Chevy and on the Dodge about the truss maybe having to be a little bit easier on the Dodge, just because on that one there's already 4-link bars. You see that little area there? That's what that was. So here's the sub-assembly. Everything on top of this bags are going to be the things that bolt on the bags and any of the other bracketry that holds on to the frame rail. So for instance, you have this that holds the bag, and then you have like this piece here that actually holds the pan hard bar or the track bar, depending on what you want to call it. You know, it just locates the axle from left to right. But here you see the truss. So let's imagine that these tubes are the actual diff, and then this plate on top is the actual truss work. So what this does is it serves a couple different purposes. It'll reinforce the axle, and it'll also serve as a mounting point for different fixtures. On this car originally there was leaf springs, so everything that's on the truss is now replacing the leaf springs with the airbags and these 4 points that identify the 4-link bars. And then in the front, like I showed you, the pan hard bar. On the Dodge, we already have those 4 points. We also already have a pan hard bar. So we might not have to make a truss this big or this sophisticated, or when we get there, we might decide, hey, let's just eliminate everything and make like a big truss to match this one.
Here in the rear is exactly where we want to show everybody where we shine. So this truck comes with a heavy duty axle, usually with a Spicer or a Dana, a really, really big axle setup. We can make a 6x6 by keeping this current axle, maybe adding another axle, shifting the axle. That's not what we do. We don't want to keep this axle. Number one, we don't care for the gear ratio. Number two, we don't care about the axle size. And our payload is going to depend on actually having tandems as opposed to one beefy axle. The tandem axle that we switch for is 2 corporate 14s with steerable ends. The steerable ends are actually, you know, off of a Dana 60. We use those axles on here, but we don't make this truck any longer. We keep the same truck for pretty much every build we do. We use an 84-inch cab to axle dimension. So when we put the other axle a hair aft of this axle, we keep the same wheelbase. So people might think, oh, a 6x6 truck, that's unpractical to drive, or it's way too long. Well, it's not unpractical because it's steerable, and it's not longer than stock because we keep the same chassis. Now, the beautiful part about these steerable axles is all of the fabrication work that goes into them. We build a truss that goes on the axle. The truss is responsible for like 5 different things. One of them being holding the 4-link bars. The second one being holding the pan hard bar. The third one being a steerable axle that self-centers when you let go, because steering in the rear is only used when you're trying to park somewhere fancy, if you want to crab walk at a show, or if you want to back in a trailer or something like that. And the other thing that the truss also does is that it houses our air suspension. All of these trucks come with an air suspension. Our air suspension design is very different than everybody else. You have a lot of guys using semi-air suspension bags or other types of bags off of other cars. We use a very, very unique and different bag, and you'll see later that I'll explain to you. It's a Slam Specialties bag. But our trick to these air suspension trucks is that the trucks always stay within that comfort zone, which is between 60 to 90 PSI, whether you're loaded or unloaded. And that's the beauty of having a tandem axle setup, because you don't just get more load carrying capacity by increasing the pressure on the bag to a ridiculous amount over 100 PSI. You just have 4 bags, which means you have that load carrying capacity.
So to explain a little bit more about our air suspension and what makes it so comfortable, I got to explain to you the 3 most commonly used airbags and what makes them different and what makes ours slightly a little better. Here we have a single bellow bag. It's a very commonly used bag. It's an actual comfortable bag, but the load capacity behind it isn't the best. Here we have a tapered sleeve. It's the most commonly used bag, and a double bellow bag, which is what we are using. These 2 charts are going to represent the pressures and the points at which these bags are designed to use. On this tapered sleeve bag, that red line indicates the pressure that the bag is ideally supposed to have at a specific height. These bags are designed to operate at a very, very specific height. Any skew from this height actually will make the bag more uncomfortable, either bouncy or stiffer, depending on obviously whether you have higher pressures for a heavier load or lower pressures for less of a load. But that height is very specific to these tapered sleeves bags. These bags are usually used on semis and on trailers, where the application always holds the same height no matter what. The weight rating is increased, then the pressure is increased, but the bag stays and is supposed to be at the same height. As opposed to this RE8, which you're seeing here, which is similar to the bag we use. We actually use an SS8. If you see this little square that's getting outlined right now, these is the ideal pressures that are supposed to be held with the ideal height. The ideal height for this bag is going to be between 6 and 10 inches with an ideal pressure rating of 80 to 100. It's not to say that if we need to load up and get more of a load, then we can move up to about 200 pounds. But within this range, you can see the amount of weight that a single bag can carry. But that weight rating will start getting displaced or reduced based on a height.
All right, guys, well, there you have it. It's a little brief summary on what it is that's gonna go down on our 5500 Laramie Limited that we just picked up. So make sure you stay tuned and you subscribe to that YouTube channel. You're gonna see this whole build unveil live.